Hello, this video is to help with Chapter 8, Tech Project, and we're going to be looking at Part 1 in this one. So Part A asks us to enter and name, or better yet, load the data from exercise number 72 from section 8.3 into the text. So I'm going to be working with a different data set just so that my answers aren't exactly the same as yours, but this should still be a very good example to lead you through the process. And I have that data set loaded into Statcrunch already, and it's a medium-sized sample, 24 pieces of data, which I believe is similar to what you're working with. So the data's in, and then comment on the requirements for computing an interval. So you can't really tell that just what type of interval it is from just looking at this, but if you go look at the problem in the book, you'll see that it's a confidence interval for the mean. And with intervals for the mean, we're concerned with whether we have a small, medium, or large sample. And our sample size here is 24, so that's a medium-sized sample because it's in between 15 and 30 pieces of data. And with a medium-sized sample, you need a population that is not severely skewed, and I believe the problem does not state what's going on with the population. So here's what I'd write up on that. Because my sample size of 23 is in between 15 and 30, and let me just double check that. It's actually 24, so quick fix there on this part. So because my sample size is 24, which is between 15 and 30, and the population distribution is unknown, I have to hope that the population is not severely skewed, and that is so that x bar will be normally distributed. This is what I really need, is for x bar to be normally distributed. And that should happen if your sample size is medium and the population is not severely skewed. But the population is a mystery, so we're stating that we are hoping for that. Alright, going back to the tech project, Part C says to create a box plot for the data set and make sure we select horizontal, drawing horizontal and fences to show outliers. So I'm going to go back into Statcrunch. I'm going to go to Graph and Box Plot. I'm going to select the data. I'm going to check Use the Fences and draw boxes horizontally and compute. I always think these show up a little bit too tall, so I'm going to resize that. And then I'm going to start thinking about how that relates to Part B. So in Part B, we said we needed a population that is not severely skewed. So what you would look for here is for an imbalance in the whiskers. So if you had a really short whisker on one side and a long one on the other, that would be an indication of a severely skewed population. Here my right whisker is a little longer than the left, and the right side of the box a little wider than the left. Those are indications that possibly my population is slightly right skewed, but it's not severe. If it was severe, you'd expect the short whisker to be real short and the long side whisker to be very long and probably even have some outliers. So with this being roughly symmetric, it looks like we're in pretty good shape. So let's go ahead and take this and put it into our report. So I'm going to use the snipping tool for that, which I actually already have opened. And I have a capture here. I guess I'll just go ahead and do it again for you. So click on New. You can highlight the whole window, or you can just highlight the part that has a graph. Either one is okay. I definitely prefer the snipping tool over using the Statcrunch options. I think it's just easy and you get what you want only. So edit, copy, and move this out of the way, and I'm going to paste that in. So normally people go to paste that right after C, and I'll go ahead and do that. And if it's a little smaller, which I'll shrink it down, then the label ends up at the very bottom of the graph, which to me doesn't make sense. The label should be at the top. So if you click on that graph and then left arrow so you get the cursor in the front and you press enter, that'll slide that down onto a new line. You can hit tab and move that over. And I think that's a better look in the report to have the label up above the graph. And then here's a write-up of the explanation I gave you just a moment ago. The right side of the box a little wider than the left, so on and so on. Same stuff I said a moment ago. And it's important to note that that means it seems reasonable to assume that the requirements have been met. I don't say the requirements have definitely been met, because I'm just guessing at the shape of the population by looking at a box plot from the sample, which has the possibility of random variation throwing us off from the truth, but when I look at this box plot, it does not seem like it came from a population that's severely skewed, so I feel pretty confident in assuming the requirements have been met, but I don't know that for sure. Okay. Alright, so what I just showed you is fine for this problem, but let me show you some variations that you might see when you do yours. I'm going to look at the box plot simulation, and I'm going to set the sample size to 24, and then I'm going to create a random, or choose from a random population and get data. And what I want to see is if we can tell when we have a severely skewed population. This population, to me, this is the sample, but it looks like it's maybe left skewed, but not severely. Again, a little wider here, a little longer on the left than the right, but it doesn't look severe. And if I mouse over that, it'll tell me the answer. So the real population is uniform. I think that box plot gives some hints of left skewed, so I might have identified it wrong, but I still picked something that was not severely skewed. So as long as I don't pick that part wrong, if I pick something that would have satisfied the requirements and it turns out it's something else, but that still would have satisfied the requirements, then in a way I haven't made a mistake. So that's what we're hoping for on these. Let's try another one. Now this time it looks like there's a more severe skew. The right whisker is short, the left whisker is very long, and the left side of the box is longer than the right. I would be a little worried on this one. If I need a population that's not severely skewed and I get a left whisker this much longer than the right, that would cause me concern. I'm not positive whether this is left skewed or severely left skewed, but it looks like it might be severely left skewed, and that would worry me in terms of the requirements. It turns out it's just left skewed, right? So this would be one that would be tricky. I would have to say on this one, if they asked me how does it met the requirements, I would say I'm not sure. The left whisker is so much longer than the one on the right. We might have a severely left skewed population, which would violate the requirements. So this one would technically be okay because it's just left skewed, not severe, but the box plot would make you worry because of the size of this whisker compared to that one. Let's try another one. This one I wouldn't worry about because first of all, most of the variation in the middle, not in the whiskers, and the whisker size difference is not that big, so I'm not sure what this population is, but I don't think it's a severely skewed one. Turns out it's bimodal. So bimodal is okay, not severely skewed. It's a symmetric population. Let's try one more. Now, this one is tricky because the whiskers seem symmetric, but you have two outliers way over here. When you're thinking about shape of the population, imagine the whisker going all the way to the outliers. So if you do that, we have a much longer left tail than right, or left whisker than right, and a longer left side of the box. So this is again probably either left skewed or severely left skewed. I think severely left skewed. So if this was my graph, I would feel like I had not met the requirements. Let's just check on that. No, it's just left skewed again. So let's look at what severely skewed looks like. So here's severely right. That's one look. Here's another one. There's another one. These are all random samples of size 24 from a severely right skewed population. What you'll notice is a long right whisker and a short left one. There's another one, short left whisker, long right one. So it's a huge difference, right? Tiny whisker, very long. This time, random variation threw us off. If we saw this one, we might think we were okay, but it's severely right skewed. So we're always struggling a little bit to make these decisions, just looking at sample data. But that gives you a sense of it. The worst kind of skewing is exponential, and usually you'll be able to tell that, especially if you imagine the whisker drawn all the way to the outlier. Very long whisker on the right, very short on the left. All right, so that's what a lot of different cases can look like. This case now compared to some of those we just saw is easier, a little bit longer on the right than the left, but the population is maybe bell-shaped, maybe it's right skewed, but either of those would be okay. All right, so finishing this off, part F asks us to, well, let's see what part F asks us to do. Create a 95% confidence interval by using these steps. So let me go ahead and show you that. So we go into stat, and for means, that's a t-test. The formula for confidence interval for the mean is x bar plus or minus t times s over root n. So because of the t, we use the t stat. We have one sample. We have the data there. The data is here. We're going to click on confidence intervals. This already says 0.95. If you needed a different level, you could type it in there. And there's nothing else that we really need from that, so I'll just click compute. And then here's my results. And you can just copy and paste that. You can also use the snipping tool. I'll go ahead and do that. So there's the output that I need. And I will copy that and paste that into the report. I would have the same problem here with that, putting the label at the bottom, so I'm just going to anticipate that, press enter and go down a level, and then paste that in. And then let me just show you one last part on this. Going back to the project, part G says Statcrunch does not use interval notation in our answer, and they want us to rewrite it using that standard interval notation style, including the appropriate symbol. So a lot of people get confused here and think they need to go do the confidence interval by hand. All I'm asking you to do is write out or type out the interval. So let's look at the report. The lower limit is the left side of the confidence interval. The upper limit is the right hand side. So I'm going to insert an equation here because I'm doing some math sort of stuff. This is a confidence interval for the mean, so it's mu that I think is in this range. So I'm going to go find that Greek letter mu. And then I want the is an element of symbol. So I'm going to look around for that. Don't see it there. Here it is. And then I want to do an interval, so open parentheses. The lower limit is this number, so 3.929467. If you want to round that a little bit, you can. Or you can type it all, either way. And the upper limit is the other side, 4.5788664. And now I have my confidence interval written in the normal style for a confidence interval, in interval notation. So we're not doing any math right here. We're just taking their answer and rewriting it in the way that we normally would. Of course, all your numbers will be different because you're using different data set, but it's still the same idea. Part H is interpret the interval in words, pretty standard. Part I is to give a yes/no answer, and you have examples of that in your notes from 8.3, so you can take a look at that to think about how you would answer that one. But I'm going to go ahead and cut off this video there. Good luck with this.